Chapter 1 Number System. There are two types of number, real number and complex number. In Lesson 1.2, we learn complex number. There are 4 learning outcomes of complex numbers as given below. What is complex number? How do you solve x squared plus 1 equal to 0? So easy, right? You get x equal to plus minus square root negative 1. Good. But when we use calculator, key in square root negative 1, we get math error. Why? It is because square root negative 1 is not a real number. It is complex number, written as I. Complex number can be written in Cartesian form, z equal to x plus yi. Both x and y are real number. X is known as real part, y is known as imaginary part. Examples. For complex number, 1 plus I, real part is 1, imaginary part is 1. 3i, real part is 0, imaginary part 3. 5, real part is 5, imaginary part is 0. When we want to simplify complex number, 4 important operations can be applied here. They are equality, addition, subtraction, and multiplication. We will discuss them by doing the following example. 2 complex numbers are said to be equal. A plus bi equal to c plus di if and only if a equal to c, b equal to d. Example. Find the values of a and b. To find the values a and b, use comparison method. For real part, a plus b on the left equal to 6 on the right. A minus b on the left equal to 4 on the right for imaginary part. Solve these 2 equations simultaneously and we will get b equal to 1, a equal to 5. We can simplify 2 or more complex numbers by additing and subtracting. For example, simplified 8 plus 3i plus 4 minus 5i. For real part, 8 plus 4. For imaginary part, 3i minus 5i. Simplify it and we get the answer. Multiplication of complex numbers. Example. Simplify 8 plus 3i multiply with 4 minus 6i. First, we expand it. Then we substitute I squared with negative 1. We simplify it further and we get the answer. For the following example, please read the question carefully. The important information is z equal to 3 plus 5i, where tips here, I equal to square root negative 1 means I squared equal to negative 1. We want to find the values of x and y. First, we substitute z with 3 plus 5i, simplify it, and then we expand it. We have I squared. We only substitute I squared with -1. And then we get the answer in a plus bi form. To find the values of x and y, we compare left hand side equal to right hand side. So we have x equal to -55 and y equal to 15. Simplify I to the power of n. We know that I equal to square root -1. So I square equal to square root -1 times square root -1 equal to -1. I to the power of 3 equal to I square times I equal to -I. I to the power of 4 equal to I square square. We get -1 square equal to 1. Let us simplify the following functions. A square root -81 For B, first we expand it. We substitute I to the power of 5 as I and I to the power of 3 as -I. We get 2i. Conjugate of complex numbers. If z equal to a plus bi is a complex number, then its conjugate denoted by z bar or z star. The conjugate of a complex number is obtained by changing the sign of the imaginary part. Example, if z equal to 3 minus 2i, then conjugate is 3 plus 2i. If z equal to -5 plus 3i, conjugate is -5 minus 3i. When z multiplied with conjugate, the I can be eliminated. Example, 3 minus 2i multiplied with 3 plus 2i. We expand it and simplify it. And we get 13. Division of complex numbers. To divide two complex numbers, multiply the numerator and denominator by the conjugate of the denominator. We will discuss the following examples. To simplify 8 plus 3i over 2i, first, the conjugate of denominator 2i can be -2i or 2i. Here we choose -2i. We multiply numerator and denominator with -2i. Expand it and then substitute I squared with -1. Finally, we get the answer in a plus bi form. Simplify 5 plus 3i over 5 minus 3i in the form of a plus bi. First, conjugate of 5 minus 3i is 5 plus 3i. Multiply the conjugate both numerator and denominator. After that, expand it and substitute I squared with -1. Simplify the answer in the form of a plus bi. Read the question carefully. To solve it, first we express z1 squared over z2 in the form of a plus bi. Then only we get the conjugate from it. Example, if z squared equal to 8i, given z is a complex number, find z. For this question, the important information is z is a complex number. So, we must let z equal to a plus bi. Then, we can proceed the following steps. To enhance your skills, please do the following exercise. Argand diagram. Complex number can be represented on Argand diagram. X-axis for real part, Y-axis for imaginary part. For example, z equal to 3 plus 2i, we can get like this. Z equal to 4 minus 5i, we can draw like this. Modulus and argument. Modulus z of complex number is given by square root a squared plus b squared. It measures the distance from origin to P. Arguments, it measures the angle from x-axis to line OP. Formula argument, theta equal to a tangent b over a in radian. Example, find the modulus and argument of each of the following complex number. The value of argument depends on which quadrant the complex number is located on an Argand diagram. Example, we want to find the modulus and argument for z equal to 2 plus I. Z equal to 2 plus I, it is on the first quadrant. Modulus z is square root 2 square plus 1 square equal to square root 5. Argument of z, tangent theta equal to 1 over 2, theta equal to a tangent 1 over 2 equal to 0.4636 radian. For z equal to 2 minus I, it is on fourth quadrant. Modulus z equal to square root 2 square plus -1 square equal to square root 5. Basic angle alpha equal to 0.4636 radian. Since z on the fourth quadrant, theta equal to negative alpha. So, theta equal to negative 0.4636 radian. For z equal to negative 2 plus I, it is on the second quadrant. Modulus z equal to square root negative 2 square plus 1 square equal to square root 5. For argument, theta is measured from origin. So theta equal to pi minus alpha, where alpha is basic angle. Therefore, theta equal to pi minus 0.4636 equal to 2.678 radian. For z equal to negative 2 minus I, it is on the third quadrant. Modulus z equal to square root negative 2 square plus negative 1 square equal to square root 5. For argument, theta equal to negative of pi minus alpha. Alpha is basic angle. So we have answer negative 2.678 radian. The following diagram are summary for the argument of all quadrants. Next part is polar form of a complex number. Complex number z equal to a plus bi is in Cartesian form. From diagram, cos theta equal to a over modulus z. A equal to modulus z cos theta. Sin theta equal to b over modulus z. So b equal to modulus z sin theta. To transform z equal to a plus bi, Cartesian form, to polar form, we need to substitute a and b. So we get polar form remarks. Modulus z can be written as r. Example, express z equal to negative 2 plus I in polar form. From previous example, we have found modulus z equal to square root 5, argument z equal to 2.678 radian. So, in polar form, complex number equal to square root 5 cos 2.678 radian plus I sin 2.678 radian. Now you can try the following exercise.